So this is a paper that is jointly with Nicolas Debarcy. And the title has slightly changed indeed. It's now about the empirical content of spatial spillovers, identification and causality in spatial econometrics. The idea is that we started several years ago with Nicolas Debarcy to exchange about our views with respect to applied spatial econometrics and how it was evolving. And we were both kind of a state of a certain dissatisfaction, in fact, at some of the main aspects of applied spatial econometrics. So we started exchanging, and this is the result of these exchanges that I'm going to present to you today. Okay. So the overview of the presentation goes as follows. Spatial econometrics people among you might know what is the first item of this list is about. Is spatial econometrics still pointless? It's of course in reference to a strong criticism that appeared now 10 years ago by Gibbons and Overman, who pointed precisely that spatial econometrics was mostly pointless due to its inability to correctly tackle inference, identification and causality issues. So here our question is basically, where do we stand 10 years after this criticism? And this leads us to really try to look at how spatial econometrics approaches, or rather how it doesn't approach identification or causality, and how other literatures such as network econometrics or reduced form potential outcome approaches to identification deal with the issue of spillovers, interference, and how it can help us think about these topics in spatial econometrics. It might be not very humble to say so, but using all these literature, what we try to do is to state what lessons can be drawn for the current state of applied spatial econometrics, and to provide some guidelines into an applied spatial econometric work. So first I will start with this idea of what is the empirical content of spatial spillovers. If you read a regular typical paper in, let's say, regional science or applied spatial econometrics, the story usually goes like that. So you have this idea of analyzing the impact, and I put impact like that in brackets, because so we want to analyze the impact of some explanatory variables on some explained variable. Okay, so let's look at the impact of density on the productivity of cities. Let's look at the impact of pollution on the growth of cities. Okay, and then the data that are at hand have a georeference dimension. They are geocoded. So because they have this spatial dimension, well, there is a need to account for this in the specification, because since Tobler and the first law of geography, whenever we have georeference data, there is this idea that we have to deal with spillovers and spatial externalities and things like that. So we have a spatial dimension, and in order to tackle this spatial dimension, we have a choice between a set of spatial specifications, which usually go like that. So this is a typical graph that you can see in spatial econometric textbooks. So on the right, you have the simple OLS model, and then you have various possibilities of spatial models, like the spatial lag model, where you would say that I don't know if you see my mouse here, but if y in a certain location depends on the y's, so the explained variable of neighboring locations controlling for other variables. So you have like substantive spatial spillovers, or you have a spatial error model where the spillovers go into the error terms, and then more models, and mostly used is the so-called spatial Durbin model, where you have this endogenous spatial lag here, WY, so, and also exogenous spatial lags, WX. So basically, the outcome in one location depends on the outcome of the neighboring locations, and also upon the characteristics of the neighboring locations. Okay, and between all these models, you can go from one model to the next by specifying various constraints on the parameters. And these are typically tested using the three major possibilities of testing that we have in econometrics, which are Wald test, Lagrange multiplier test, or likelihood ratio test. And from a historical point of view, because at the time, these spatial models were quite difficult to estimate, because there's the so-called problem of the Jacobian in maximum likelihood estimation. So it was quite costly to estimate. So the practice has long been in applied spatial econometrics to start with this simple OLS model, and then to do Lagrange multiplier tests, which can be done on the residuals of the OLS models to see whether we need to go to more sophisticated spatial models. And so we have all this literature in spatial econometrics about the so-called specific to general specification search, where we start with the OLS model, and then we let basically the data decide based on these Lagrange multiplier tests, which of the spatial specification is the most relevant. So, and this is still typically often done in current applied spatial econometrics regional science papers, where these are the LM tests, which derive the chosen spatial specification. And then once the spatial specification has been estimated, we discuss the implication in terms of the implied spatial spillover, because depending on whether you have an endogenous spatial lag, WY, or exogenous spatial lags, or both, or whatever, or if it runs through the error terms, then the spillovers are global, local, etc. Okay. Once you've done that, whenever the specification includes an endogenous spatial lag, a WY, then there is the point made by Lesage and Pace in their classic textbook, where they say that the coefficients in such spatial models cannot be interpreted as marginal effects. So in order to have the effects, we have to compute that kind of impact, and they call that impact. Okay. But the problem with that kind of approach, which is really typical in applied spatial econometrics, is that spatial spillovers are really, and most of the time, the focus of interest in that kind of paper, but they essentially appear as a byproduct of a data-driven specification. So we do tests. The tests tell us which spatial specification fits the data the best. And then we discuss spatial spillovers and what they imply. But then if you do this way, if you have this really completely data-driven approach, what is the real empirical content of spatial spillovers that you are discussing and trying to estimate? And this really pertains to the fundamental question of identification. Identification and causality. So we know that since the so-called credibility revolution, where we have this very strong focus on the notion of identification. So these authors, they advance the use of experimental and quasi-experimental methods to achieve identification and causality, and all the applied papers in major economic journals, they go through an identification strategy, which is really the way in which a researcher uses the observational data to approximate a real experiment in order to be able to interpret, to have a causal interpretation of the parameters. Now, if you look at a little bit at the history of econometrics in general, then it's, of course, this is the very trendy way of doing applied econometrics these days. Yet it's not the only way to achieve identification and causality. And there is a very nice paper by Lubel in 2019, which is called the Identification Zoo. It's in Journal of Economic Literature, and he defines at least 24 terms for identification that appear in the literature: point identification, partial identification, Bayesian identification, non-parametric identification. So you can do your market in that, but basically, if you want to categorize things, you can achieve identification in structural models where everything is completely specified, or in the so-called causal reduced form models. What about spatial econometrics in this story of identification? Well, besides the major point that was made by Gibbons and Overman 10 years ago, other authors have already criticized spatial econometrics on this specific question of identification and causality. I'm really not going to talk here about the use of that kind of models for prediction purpose, for instance, because in that case, the idea is a bit different. But here, in the context of identification and causality, you had this statement of Moore already back in 2013. Says that, well, maybe it's a question of the discipline's full maturity and personality, and also that its evolution has mimicked that of the time series literature. And this is very important because indeed, from a historical point of view, this is exactly what happened. So causality plays a minor role. And then you have this other statement by Partridge and co-authors, who state that a common complaint is that standard spatial econometrics does not do a good job at differentiating when outcomes in nearby area are spatially correlated versus spatial causality when outcome in area A affect outcomes in area B. In other words, the usual spatial specification are not able to disentangle the various mechanisms that might drive spillovers. And then you have this very big criticism that was made by Gibbons and Overman. So it was in a special issue in Journal of Regional Science 10 years ago. And they were very strong in their criticism with a very markful title, Mostly Pointless Spatial Econometrics. And what they say is that precisely all these identification problems, they bedevil applied spatial econometric research. Because if you go back to the story I was telling you about a typical applied spatial econometrics paper is that how does spatial econometrics solve the problem of identification? It's by deriving estimators, assuming that functional forms are known, and by using model comparison techniques to let the data choose between competing specifications. At best, we only have in that way very weak identification, or worse, most of this whole process is pointless. So they advocate an alternative approach, which is the experimentalist paradigm, which puts issues of identification and causality at center stage. So we had this very strong criticism 10 years ago, and now 10 years after that, where do we really stand? And if we look at top field and top 5 papers in economics these days, we do not see any spatial econometrics. We might see network econometrics, we might see structural spatial models, but we do not see spatial econometrics with the spatial specification that I just showed you before, and the way it is done in more regional science approach. And why is that? As an illustration of this trend, I have this, we have fiscal federalism. So in fiscal federalism, the idea is to estimate policy reaction functions on taxes, expenditures. So we see how a jurisdiction reacts to taxes of its neighbors or expenditures. And then the first generation models that were estimated to see whether there are, in fact, that kind of policy reactions are basic spatial lag models. So in the early fiscal federalism literature, you have spatial lag models as you have them in any textbook on spatial econometrics. So where you have, for instance, the tax, the level of tax in jurisdiction I at time t is a function of a weighted average of the taxes set by the neighboring jurisdiction at the same time, plus control variables, plus fixed effects, and so on. But these models were rapidly criticized in the fiscal federalism community because the exclusion, they were typically estimated using two-stage squares, but the exclusion restriction is almost never discussed. In fact, this kind of spatial lag models are estimated using two SLS, two-stage squares, and to estimate this spatial lag term, we use as instrument wx, w squared, x, etc. So the exogenous spatial lags, the spatial lags applied to the x's. But the relevance of these exclusion restrictions were almost never discussed. And the using x's is not as instrument, or wx, or the spatial lag of these x's, is quite problematic because they might include characteristics that are subject to self-selection, Thiebaud sorting, etc. And I'll come back to that later, they can also be very weak instruments because they are very collinear, wx, w squared, x, etc. And also these first generation models were unable to discriminate between all the mechanisms that can drive these interactions between jurisdictions. So if you look now at the recent applied fiscal federalism literature that goes into top field and top 5, you do not have any kind of spatial econometrics anymore. They all make use of forms of quasi-experiments. They use discontinuities, they use instrumental variables, etc. But no standard spatial econometrics. So we want to come back to that because this was really a question, is why spatial econometrics has disappeared in big journals today, whereas it existed 10, 15 years ago. You can find papers that went with that kind of approach. And this is really linked to this Gibbons and Overman criticism on the mostly pointly criticism. So here we discuss this question of identification and causality, looking from both grounds. First, starting with a very structural approach, which is really linked to what current network econometrics is doing. And second, by looking at basic Rubin causal potential outcome approach, and how people in statistics and biostatistics deal with the so-called problem of interference, which is the SUTVA issue, the stable unit treatment value assumption. And we state the crucial role of spatial heterogeneity in identification, which is something that is mostly overlooked, in our opinion, in applied spatial econometrics. And we try to draw some lessons for a spatial identification strategy. So first, quickly, what is identification? The point identification goes like that. A parameter theta is identified if there do not exist any pairs of possible values theta and theta tilde that are different but observationally equivalent. Theta might be anything we want. It might be structural parameters. It might be average treatment effect. And the idea is, what can we learn about the population parameters if we observe a sample, and if we can learn something under which conditions, which is basically the identification strategy. And importantly, which is something that is not that clear in some applied papers, is that the study of identification logically precedes estimation, inference, and testing. So you should first ask yourself, what is my identification, before asking yourself questions about methods of estimation, inference, and testing. Okay, now if we apply that to models of interactions, okay? So here, people that have done a little bit of spatial econometrics in your life, you recognize here a basic spatial Durbin model. So again, you have the outcome in one location, which depends on the outcome in other locations, and which other locations, it's determined by this weight matrix W, who specifies which specifies the connectivity structure between the observations, then the control, the other control variables, and then the spatial lag of these control variables. So the outcome in one location also depends on the characteristics of the neighboring locations. For instance, when there are shared infrastructure, it might, or things like that, okay, or mobility of population or employment, and so on and so forth. So this is, let's assume this is your structural model, and your objective is really to identify these structural parameters, lambda, which is called in the network literature, the linear means model. This is the endogenous effect. Beta and gamma, the exogenous effect. And then we have something in the error term. And we want to identify these structural parameters from a sample of data. Now, in spatial econometrics, this spatial Durbin model is very, very successful. Lots of applied spatial econometric papers estimate some form of a spatial Durbin model. And this is so since the so-called motivations by Lesage and Pace in 2009, their textbook, because what they say is that the spatial Durbin model has many virtues. It has a lot of advantages. First, because it encompasses many models. So if you estimate a spatial Durbin models and you make tests on the coefficients, you can arrive at simpler spatial models. But also a very strong point of theirs, to which we will come back, is that it is a good way to deal with omitted variables. Under certain conditions, it can still yield consistent estimates, even if you have omitted variables. We will come to that motivation later. It can deal with unobserved spatial heterogeneity. It can deal with uncertainty. So, I mean, this is some kind of an ideal model for a spatial econometrician. So they really root for the spatial Durbin model as being the point of departure of basically anything. If you know a little bit about the reflection problem, Mansky's reflection problem in all the network peer effect literature, you would know that this kind of model, sometimes it's not with W, but it's called J, whatever. It's the linear and means model, so lambda endogenous effects, gamma contextual effects, and you have correlated effects such as common shocks and things like that. If the conditional expectancy of the error term conditionally to X and importantly W is not equal to 0. In this case, you have correlated effects. So you might have problems with X's, but you also might have problems with W. So this model has a long history in spatial econometrics. It has first, if you go back to the seminal papers by Cliffenord and Luc Anselin and people like that. And now you have lots of papers by Lung-Fei Li and co-authors, and they all go with estimating that kind of model with quasi-maximum likelihood. But quasi-maximum likelihood implies very strong assumption on the functional form. It states that we know the functional form on W, which is supposed to be known, and also on the error distribution. So it's really a purely structural approach. But sometimes we apply maximum likelihood and we're not in a structural approach. But if you believe that kind of thing, if you use maximum likelihood, then it's because you put yourself in a purely structural approach. Later on, and these are the papers by Kilijian and Prucha, it was also estimated by two-stage G-squares or GMM, because quasi-maximum likelihood, as I was saying a little bit before, it might be very costly to estimate because of the Jacobian term, which is the determinant of I minus rho W. When we didn't have the computers that we have now, it was taking a long time to estimate and lots of problems. And this is why we had all these Lagrange multiplier specific to general specification search. It was because it was so costly to estimate spatial models that we wanted to be sure before estimating them that it was worth the price. Okay. So then, Then later on, so two-stage G-squares or GMM that avoids computational burden, that also allow for additional endogenous regresses. But how do we estimate typically a spatial lag model? The proposals by Kilijian and Robinson was to use purely internal instrument, without what I was saying, WX, W squared X, etc. And this is quite problematic because why should these instruments be excluded? It's almost never discussed. And this also might be very weak because they are very correlated. And more fundamentally, this kind of way of dealing with endogeneity is rather mechanical. It's not theory-based. We do not have an underlying system of equation. Okay, so the question of identification in traditional spatial econometrics, in our point of view, was not really addressed. Now, if we want to address identification in typically a spatial Durbin model, okay, what are the threats to identification? The first threat pertains to W. Then we might have issues with omitted variables. And then we also have everything that goes around spatial heterogeneity. First, W. Why and how can it be a threat to identification? In the initial reflection problem by Mansky in 1993, in his paper, he started with groups of equal size where everybody in each group was interacting with everybody else. So basically, you had a block diagonal and idempotent W. Okay. What Mansky said that in this case, even if you don't have any kind of correlated effects, that is, you have no self-selection, you have no sorting, you have all these problems linked with unobservables and things like that. But even if you don't have all these issues, then you are not able to disentangle, to separately identify endogenous from contextual effects. That means you cannot say whether you have peer effects, substantive peer effects. I have the same outcome because I do something because my neighbors did so himself, or because I have the same characteristics than my neighbors. Okay, this is the reflection problem. So the various solutions that have been proposed, and this is more network econometrics references. So in Brock-Durlauf was shown that if the response is discrete, then you can in some way circumvent the reflection problem. Or you can specify groups of heterogeneous size. So that's a paper by Lee in 2007, where you have, if you have sufficient groups of sufficient heterogeneous size, then you can deal with the reflection problem. Or there are also solutions that are based on experimental designs. And of course, you have this proposal by Bramoulet et al., Calvo, Armengol et al. In 2009, where they use a property of incomplete networks, because they really specify this idea of in networks. So they say that basically, if you have intransitive triads, that is if some of my neighbor's neighbors are not my neighbor, so intransitive triads, then we can solve the reflection problem. Okay, but you still have to assume that you have no correlated effects, because if you have correlated effects, then you have other kinds of issues. But if you have no correlated effects, and if you have so-called incomplete networks, so these intransitive triads, then there is identification in this context. And this has a posteriori given some explicit conditions for the early papers of Kilijian and Prucha, because we know that when we use spatial-based weight matrices like contiguity matrices or nearest neighbors matrices, or distances or matrices based on distances with thresholds, then we have this condition that is verified. We have sometimes my neighbor's neighbors are not my neighbors, okay? Structurally, in the case of space. So we could say, okay, well, spatial econometrics with this spatially exogenous weight matrix, everything is okay because we verify this theorem. However, of course, we have all sorts of questions about the relevance of these geography-based weight matrices, because we have a full set of possibilities and no really clear rules about how to choose among them. Now we might have problems, even in the case of space, of W matrices being stochastic. Okay. If they are stochastic, but they remain exogenous in the sense that they remain independent of the error term, then there is no problem of identification. But you might still run into problems when you want to evaluate the impact of a policy. And this is really more in the network literature that you can find that kind statement. Of course, you might also have stochastic and endogenous weight matrices, because you have all this literature that exists even in spatial econometrics, where you put not only spatial exogenous criterion, but also you want to include socioeconomic similarities, for instance. So in this case, you potentially have endogenous weight matrices. And so there are a series of papers that deal with that kind of problematic, in particular these papers, quite recent, with control function approaches. Other papers also look at the impact of having only a partial knowledge of W. There is a very large literature dealing with the impact of misspecified W in a spatial context. What happens if we have location measurement error? What happens if we have spatial censoring and things like that? But all these papers really focus on the impact on estimation or inference. And there is only one paper that we found that tackles the issue of misspecified W for identification itself. It's a paper by Conley and Topa in 2003. So there's probably room here to do more research on that issue. As I was saying to you earlier, in spatial econometrics, the SDM is heavily used in applied spatial econometrics because it is often presented as a solution to spatially autocorrelated omitted variables. But this is an argument that is, of course, only valid if all other threats to identification are controlled, okay? Which is often not discussed. And another issue that we point is that if we have this condition that is verified, then the spatial Durbin model boils down to a spatial error model, where the spillovers run through the error terms, which is really not the same story, you know, where you want to have a story about endogenous and exogenous effects, and the real model, in fact, is something that runs through unobservables. It's really not the same story to tell. And it's in some of the papers, theoretical spatial econometrics paper, this condition here really stands out at a very important identification condition for SDM. And this is not so much discussed, even though we have a test which is called the common factor test to test this set of constraints. And unfortunately, it's not applied enough in the applied spatial econometrics literature. But it is important, of course, because the implications of the model are very different. Now, we also point out the very important role of spatial heterogeneity. Because if you read literature reviews in spatial econometrics, you often have statements that, well, spatial heterogeneity, like spatial regimes, things like that, do not justify specific econometric treatment. Okay, you can just add a spatial fixed effect, or you can estimate spatial switching regressions. Okay, and that's it. It's not a big deal. It's standard econometrics. Okay, so if you read any kind of Anslin literature review or other literature reviews, and I've written that myself, well, you know, spatial heterogeneity is not much of a big issue. And it has been really undermined. But what we say is that spatial heterogeneity might affect identification in different important ways. First, because we have this problem of observational equivalence. That is, when you look at a map, you're not in a cross section, you're not able to say whether the data generating process is that of spatial autocorrelation or spatial heterogeneity. It can be both. Another way of saying the same thing is that sometimes you can detect spatial autocorrelation in your residuals, for instance. So you say, okay, something is wrong, but it can be the result of unmodeled spatial heterogeneity. So let's say you estimate a spatial model, so you draw conclusions about spatial spillovers, but really it's about unmodeled spatial heterogeneity, and that is a real issue that other people in geographical weighted regressions, for instance, have really pointed out. You might also have common factors, common shocks, common spatial shocks. And these common spatial shocks, sometimes you can handle them with spatial fixed effects, but not always. And you also have everything that is linked to spatial sorting, in the sense that individuals self-select themselves into different locations based on observable but mostly unobservable characteristics. And also these questions of spatial sorting, if you read any kind of urban economics paper, is at the center of the paper, but in applied regional science, not so much. And of course, failure to adequately control for these effects can lead to very spurious conclusions with respect to the amount or even the existence of interactions. That is, you will draw conclusions. I have a spatial lag, I have spatial spillovers, but in the end, it's not about that. In network econometrics, what do people do? They really start with structural parameters that are well defined. They start with utility functions, these famous quadratic utility functions. They really specify the main parameters of interest. Then they have this acute reflection on the role of W in identification, all these network models. And lately, for exogenous sources of variation to also put more ground in the identification of these peer effects, using quasi-experiments, etc. You also have a neighborhood effect literature, which is very structural in nature also, but not all, but where people would say that physical proximity is a proxy for spatial interactions, but we do not have any data on social interactions, so we will use physical proximity as a proxy. And for instance, there are lots of papers dealing with the moving to opportunity program. So look at what was the impact of families that were relocated from poor neighborhoods to richer neighborhoods via housing vouchers. So to deal with that, you have very structural papers, completely structural papers, or you have other identification strategies based, for instance, on this one. So more reduced form approaches. But this is a literature, neighborhood effects literature, that deals also with spatial spillover and things like that, but they really don't approach these questions using spatial econometric models. Now I turn to the other side. So we started here, what can we say about identification and causality in structural models? Now the question is, what can we say about these questions in completely reduced form models, the potential outcomes approach? And in fact, the Rubin potential outcomes framework has really become central in applied economics. Every time you want to do an ex post evaluation exercise. So this is the experimentalist paradigm. But one very important assumption that most methods in this line were doing and still do is the so-called SUDVA assumption. So the stable unit treatment value as assumption, where you state that the outcome of one individual is not affected by the treatment of other individuals. So people really, of course, acknowledged very early on that it was a very strong assumption to make. So how they dealt with this question, they first considered it as an interference. And so they focused on designs that could mitigate these interference, such as putting, for instance, at a higher spatial levels where you internalize all these spillovers and to provide robust inference. So we know that there are spillovers, interference, but we adjust the variance covariance matrix to have a robust. Okay, so this is the first strand of papers. Then if you look, and here I'm really talking about the stats, biostatistics literature, there is a progressive switch of focus to a more substantive identification of these spillovers with new causal estimates. And the spatial econometric community has also made some attempts to deal with SUDVA in for spatial issues, and we will. And there is a recent literature review on that by Kolak and Ansley. So very quickly on this Rubin causal framework. So let's assume we have a binary treatment. T is 0 or 1, depending on whether 0 is I is not treated, 1 is treated. And for each individual, there are two potential outcomes, one of which is observed. Okay, so we are interested in identifying, parameter delta, which is the difference between the two potential outcomes, but we have missing observation problems because only one is observed. And then if we go to the population level, then we have various causal estimates, the average treatment effect, the average treated on the treated, and the conditional average treatment effect, okay? Where you are conditional to a set of X variables, but these variables should be predetermined relative to the treatment. So in this context, what does identification mean? It means that a causal estimate defined for a subpopulation or the population is identified only if the counterfactual quantities can be equated in some way with observable population data without introducing selection bias. So it all depends on the assignment mechanism. If you have randomized controlled trials, so the assignment mechanism is a random draw of individuals, so you don't have any selection issues. If you do, and in other cases, you might have other assignment mechanisms based on discontinuities, for instance, and this will allow you or not to make some identification assumptions. I'm focusing here on stable, the SUDVA assumption. So the potential outcomes for any unit do not vary with the treatment assigned to other units. And the second part is not of interest for us. And the other assumptions are ignorability and positivity. What is interference in this context? So we have this definition by two biostatisticians. They say that we have interference when the exposure or treatment received by one individual may affect the outcomes of other individuals. So in order to overcome that, as I was saying, people would make, for instance, experiments at a higher spatial level so that all the spillovers could be internalized. But you also have a set of identification strategies that have been derived and that really differ according to the form of the interference that is hypothesized. The early papers in this literature assume partial or clustered interference, which is exactly the case, the initial case by Mansky. So we have two completely different literatures in different disciplines that kind of started with the same assumption of we have distinct groups. The individuals can interact within the groups, but the groups do not interact. We also have Then people started to switch to network interference. And there are also some papers that deal with general interference where we make absolutely no assumption about the form. And then once we start talking about interference in that kind of potential outcome context, it means that we have to define a new set of causal estimates. So there are many. The literature is absolutely not stabilized, but you have this paper by Hudgens and Aloran, for instance, in 2006, who defined direct, indirect, total effect, overall effects, which are then averaged, where you have the causal estimates that say, okay, direct effect is the effect of individual I to treatment J, holding all other treatment fixed as T, so that's the direct. Indirect, it's how the potential outcome from one individual is impacted by the treatment of the others and things like that. The recent literature formalizes all these things using the notion of exposure mapping, which is a function that maps the set of assignment vectors to treatments to an exposure value. And if you look at that kind of at that paper and at the papers who use the notion of exposure mapping, it's really very close to the notion of spatial lag, but it remains non-parametric. But there is this idea to formalize in some way the connectivity structure. Okay. So if you assume first unconfoundedness, so we have all the matching type identification methods, you have a proposal that has been made by Cerulli, which is basically a regression adjustment. So the potential outcome for if there is no treatment depends on the potential outcomes of the neighboring observations when they are treated. So, but this is really something that is not very popular because it really imposes a lot of assumptions of linearity, additivity, etc. And most papers, in fact, rely on this idea of propensity score. So as you know, in propensity score, in the first equation, we estimate the probability of being treated given the pre-treatment variables, and the second equation estimates the causal parameter of interest. In fact, some spatial econometric papers have done that by including a spatial lag in the first equation. So they estimate something like a spatial probit or a spatial logit in the first equation. This is really problematic because WI obviously is not a pre-treatment variable. So, and in statistics, so papers that are not in a spatial context, but more in a network context, or then you have papers that propose strategies to mimic experiments on the partial interference, or you have this this notion of Sutenva that comes from a 2021 JASA paper. So if you have confounding, I'm just going to talk to you a little bit about difference in difference because time is already running out. So difference in difference under the parallel trend assumption. So you interact basically your treated dummy with a period dummy after treatment dummy, and again, you have various spatial versions of these models that appear in papers where papers would just include a spatial error term or a spatial lag term into that, which we think is mostly not relevant. Because in particular for a spatial lag, because if you include a spatial lag in this, first, again, it's not a pre-treatment variable, and then it really affects the way you can interpret the parameter delta 4, which is your parameter of interest in this case. There are other papers, recent papers, in particular 2022 Jew paper by Butts, who relies on the notion of exposure mapping to deal with spillovers in the context, spatial spillovers in the context of diff and diff. Quickly, just to let you know that in this reduced form literature that started with very reduced form, the recent literature really tries to disentangle the mechanisms of interference. And so they start being more structural themselves, you know? So it's kind of a funny thing where you have this very structural network literature that starts to look at quasi-experiments and exogenous variations to identify parameters. And at the other end, you have this completely reduced form potential outcome literature that begins itself to be a little more structural in order to be able to disentangle between the various mechanisms. So, and in the end, you have both literature that converge in some way and with identification strategy that become quite similar. We put shock on networks and things like that. So the whole topic now for spatial econometric community is how to spatialize all these things, because for the moment they're not spatialized. What are the lessons we can draw for applied spatial analysis? First, we have to make sure that we are completely clear about what is the unit of observation versus the unit of decision. The unit that is the units that make the decisions to locate somewhere, to buy something and things like that. And what we see is that if the observations are not unit of decisions, for example, you work at some aggregate level, then in our opinion, the spatial lag coefficient is mostly not appropriate, because if we believe everything that the network econometrics literature has to say, it is a very structural way of approaching things, including a spatial lag coefficient. It's a structural approach behind you have to have. It's linked to some behavioral assumptions. And if you work in that aggregate level, mostly it's not relevant. Exceptions, if you have theoretically founded NEG models or other models that imply some form of interdependence at equilibrium. And there are some papers like that, but mostly we should preferably avoid to include a substantive spatial lag if we work at an aggregate level. Otherwise, of course, but that I will skip. Second, what is really the parameters of interest? Do you want to identify spillovers, and if yes, which ones, or another coefficient, or even both? And the story you tell and the identification strategy you use really depend on what you want to do. There are papers where the aim is to estimate some spatial spillovers, and then the first question to ask is, okay, do I have a spatial error model or spatial lag model? Well, no. If the aim is to identify spillovers, you should start with a spatial lag or a spatial dubbing and be structural and tell a story that is consistent with such a structural approach. If another coefficient is of interest and spillovers are kind of a nuisance, then maybe it's another identification strategy that is appropriate. Okay. Be careful also with these impacts by Lesage and Pace, and we're not going to make ourselves many friends in saying that, but it's not because you have computed these direct, indirect, totally effects. They cannot be interpreted as impacts. They are called impacts, but they are not impacts in the causal sense. If you want to be able to interpret them causally, well, all the other possible threats to identification should have been dealt with, okay, which is not the case typically. The case of SDM, as I was saying, the typical argument for SDM is that in the presence of spatially autocorrelated omitted variables, SDM still provides consistent estimates of parameters. Well, yes, but this is only valid if, again, all the other threats to identification has been dealt with. And it also needs that the x's and the w-axis are plausibly exogenous, which is something that is never discussed in applied, or almost never discussed. Okay. If you do not want to identify spillovers, then really SDM is not the way to go. And well, that leads to approaches. Depending on what you want to do, then you can go for structural models or causal reduced form models. If you go for structural models, then it's really important to set up the mechanism of for interactions. And if you go for causal or reduced form models, then be very careful about including WI in this story, because again, WI is not a pre-treatment variable. So you should be very careful when including that kind of variable into the story. And if you look at all what is happening in the very recent biostatistic literature pertaining to interference, a really path for research is the possibility of spatializing all these papers that are appearing just now. Weights matrix quite quickly, because there is already a very large literature on how to choose W. This really calls into question the relevance of purely geographic W. Of course, in that case, it allows identification because most of the time we have intransitive triads in there, but they may generate weak instruments. They are usually not linked to theory. And it's problematic to use and as an approximation of several channels unless you have strong theoretical arguments to say so. Spatial heterogeneity and spatial confounding. Well, this is something that is usually overlooked, but this is really something that should completely appear in its own right in any spatial identification strategy, whether can it be observable spatial heterogeneity or unobservable spatial heterogeneity in the form of spatial sorting or things like that. Inference. Again, if all threats to identification have been addressed, what should remain in the error terms are unobservables uncorrelated with the error terms. So only inference is affected. There is, of course, a need to really look at the structure of residuals in order to ensure that we have done the right thing into the identification strategy. And in this case, there are a lot of tests that have been derived in spatial econometrics that can be useful in detecting spatial patterns that could be applied in residuals to see if we are right, if we are not missing something important in the spatial structure of residuals. So as a conclusion that we put in a somewhat provocative way, it's not because the data have a spatial dimension that we should automatically estimate a SAR, SEM, SDM, etc., based on a mechanics specification search with LM test. And in this sense, we are completely in agreement with the mostly pointless criticism. And honestly, there are still way too many papers that apply that kind of story. And in our opinion, it is really meaningless. We should really stop doing that. SAR versus SEM should not be a question. If you want to identify spillovers, then the identification strategy should be consistent with the aim of identifying spillovers. And SEM, where everything goes through the unobservables, it's not relevant. Okay, but spatial Durbin model versus a pure SAR model or SEM model is important because it tells you how what are the mechanisms behind. It's not because we can estimate a model with W that we should systematically do so. And this I'm really relating to the papers that just include the WI saying that, okay, it will capture this and that. Well, WI is a really very structural way of thinking. So if you want to include a WI, it's not a trivial thing to do. Okay. And do not forget about spatial heterogeneity, sorting, and confounders. As a perspective, we had this handbook paper of blue metal back in 2012. And it was a paper about identification on the with spillovers, not spatial, because it was in the handbook of social interactions. But they say this: we believe that the econometric methodology from spatial econometrics remains underexploited in social interactions econometrics. So spatial econometricians really have things to say with respect to the identification of spillovers, but it should be done in the right way. Even Gibbons and Overman say something nice, which is probably the only nice thing they say in their paper about spatial econometrics. They say it provides important insights on the interpretation of parameters in spatial models. And which is a recent literature review about network, say that more work is necessary to explain the tremendous heterogeneity in network formation and network effects. And in spatial econometrics, there are lots of things have been done for dealing with spatial heterogeneity. So there are things that we can say about that. Other perspectives, this one seems, in our opinion, particularly important. It's the spatial networks. If you have both an information about the network structure between individuals and where the individuals are located, it really opens up huge avenues for identification. And that's it. I've already been too long. So thank you for your attention.
Merci Julie. Donc on a Hop, on a le temps un petit temps pour les questions, bien entendu, donc en français ou en anglais, comme tu l'avais proposé. Alors j'en ai eu pour lancer les questions, je peux peut-être en poser une, ou en tout cas en fait c'est plus sur les applications, notamment des expériences naturelles et quasi-expériences dans le cadre des modèles d'estimation de modèles de concurrence fiscale. Ce qu'on observe, ce que j'avais l'impression, c'est qu'on avait quand même du mal à identifier des effets, voilà, des effets de concurrence fiscale. La plupart du temps, voilà, ces papiers concluaient à l'absence de ce genre de mécanisme. Donc je ne sais pas si c'est une raison pour laquelle il reste quand même un peu de travaux sur ces méthodes-là pour les appliquer sur ce genre aussi ce genre d'application. Donc sur les quasi-expériences sur ça, et j'ai perdu la deuxième. Et puis la plupart du temps, celle-ci, elle reposait de toute façon sur des matrices de pondération spatiale qui étaient définies a priori, quoi. Donc voilà, ça permet pas je pense, de répondre à tous les problèmes liés à l'identification liés à voilà, l'estimation d'effets multiplicateurs spatiaux.
Ouais, non, mais tout à fait. Alors, effectivement, les modèles de première génération, enfin, pour reprendre la terminologie d'un récent survey de littérature par Agrawal et d'autres. Les modèles de première génération sont des modèles d'économétrie spatiale standard qui ne sont pas en capacité de séparer les différents mécanismes sous-jacents à la concurrence fiscale, plus cette histoire de W. D'où les papiers récents qui sont plus à utiliser des expériences, des quasi-expériences ou des variables instrumentales, dont notamment On utilise par exemple des closed race elections, on utilise des discontinuités, on utilise des réformes qui sont faites en instrument, par exemple, par des gouvernements ou des juridictions de niveau plus haut. Voilà. Donc il y a toute cette littérature. Alors après, je suis moins spécialiste de cette littérature-là que d'autres, mais l'enjeu est vraiment dans dans ces littératures qui s'appuient sur des quasi-expériences, d'être davantage en mesure justement de séparer les mécanismes sous-jacents. Voilà. Mais pour ce que j'en avais vu, enfin pour les papiers que j'ai lus sur cette question-là, on n'est pas du tout sur du spatial tel que voilà, on le fait là, quoi. Après, pour ce qui est de W, ça c'est l'éternel tarte à la crème. Effectivement, mais je dirais que c'est pas enfin, je sais pas si tu avais en tête quelque chose
Non, mais en
qui
fait,
serait
ouais,
spécifique à la concurrence fiscale, mais
bah ouais, sur ces papiers-là, en fait, on observe déjà des résultats qui sont très différents par rapport au modèle,
ouais.
aux estimations issues de modèles économétriques spatiaux, où en fait, voilà, on obtenait la plupart du temps des effets de mimétisme, on va dire, parce qu'on ne sait pas
Mmh.
d'où ils
Ouais.
sortaient, qui étaient quand même très forts. Et voilà. Et de l'autre côté, voilà, dès l'instant où les auteurs utilisaient plutôt des mécanismes, plutôt des approches de type expérience naturelle, bah rien ne ressortait, quoi, en termes
Ouais.
d'estimation. La plupart avaient quand même du mal à être capable de discriminer entre les différentes sources de les différents mécanismes en fait qui pourraient induire la concurrence fiscale. Ouais, ça, je pense, c'est encore plus compliqué sans peut-être une approche structurelle. Euh,
Oui.
mais,
Ouais, ouais.
euh, mais voilà, les résultats étaient assez différents. Et du coup,
Bah oui, parce qu'en fait, le modèle, les modèles de première génération, les spatial lags, c'est des termes un peu catch-all, quoi. C'est-à-dire que ça prend tout ce qu'on n'a pas mis ailleurs, mais tout. Donc forcément, dès qu'on estime ce type de modèle, on a quelque chose de significatif, quoi. Euh, ouais, c'est un peu l'enjeu. Il y a peut-être, j'ai vu
d'autres
quelque chose dans
questions?
la discussion.
Oui,
Attendez, je regarde.
il y a
Non,
vous levez
non,
la main.
there is no working paper available yet. We are working on it. Hopefully it will arrive someday. Mm.
Et je crois donc qu'on a une question, en tout cas Camille Salès a levé la main, donc je vais lui donner la parole.
Merci. Bonjour et merci pour la présentation. Alors moi, j'aurais une question. En fait, dans toutes les spécifications qui ont été présentées dans cette présentation, la plupart des données en fait sont dimension 1 ou au maximum 2. Et je me demandais si ça poserait des problèmes en fait d'avoir des dimensions de données supérieures à 2, si ça changeait quelque chose fondamentalement ou pas.
Ah oui, d'accord, d'avoir des géolocalisations, pas seulement en gros latitude de. Ouais, d'accord, je vois. Alors, je sais qu'en économétrie spatiale, il y a des choses qui sont faites avec des matrices de poids 3D. Mais il n'y en a pas beaucoup. Après, parce que forcément, c'est déjà tellement compliqué comme ça avec en 2D qu'en 3D, mais effectivement, c'est pertinent. Enfin, sur des questions, par exemple, qui porteraient sur la localisation. J'ai en tête un papier sur la localisation des entreprises dans les gratte-ciel, où du coup on regarde non seulement quel gratte-ciel, mais aussi les tâches, quoi, parce
Ouais,
qu'on sait qu'il y a qu'il y a des enjeux à être plus ou moins hauts. Et donc, ouais, c'était modélisé avec des matrices de type 3D et des formalisations 3D. Oui, ça existe, mais j'en ai pas vu beaucoup, en fait.
ok, merci.
Mais voilà, une autre perspective intéressante.
Ok.
Merci. Est-ce que quelqu'un veut prendre la parole? Pas de regret? Bon, ben, on va clore ce séminaire. Encore une fois, ben, merci à Julie pour cette présentation. Et puis, ben, on se retrouve la semaine prochaine où ben, on reçoit donc Jacques Tis qui va nous parler travail à domicile, notamment. Voilà, donc bonne journée à tous et
Cette
puis à la
saison.
semaine prochaine. Oui, cette saison.
Merci.